This is R.D. Sharma solution, class 12th. We are taking the probability chapter and third exercise. Now the initial questions are to make you aware of the formula and to use them. This is probability. P represents the probability. And this is A by B. Now first of all, you need to understand this one more time, that this is not a division. It just means you are aware, or it is being known that B, the event B has happened. Now what is the probability of A happening? That is, if B is known, what is A going to be? The probability of A. For example, if it has already rained, what is the probability of you taking the umbrella? So it is aware that the weather condition is known. So that is how the conditional probability works. A by B, A division by B is not there. It is just representation. So the formula of this A probability is PA intersection B. Now what is the common between A and B? Because B has already happened, what is the probability of A happening? Because there has to be some relationship. That is why the intersection is there. That is what is the commonality between event A and B. And what is coming to the denominator, which is PB, the probability of what has already happened. So this is the formula, the dissection I have done, and all these values which are being provided here. And if you see, this PA is already given, which is not useful here. It is already given, but people get confused. So don't worry about PA. This PA intersection B is already given, which is 4 by 13, and PB is 9 by 13. So let's write it here. We get 4 by 9. Which is the probability of this question. Now this is how you are going to write, given now all these mathematical symbols. This is very important. My intention is to give you the logic understanding, and I leave it to you. How do you write? A and B are events. A is given, B is given, A intersection B is given. You have to find out PA by B and PB by A. Let's write the formula side by side, and you will see that there are certain similarities in this formula. So PA by B or PB by A. In both of them, the numerator will remain PA intersection B, like this, PA intersection B. So the numerator will always be the intersection of A and B. What is going to come in the denominator? PB. Here PA. Whichever probability has already happened or event has already happened, the probability of that is going to come in the denominator. So A intersection B is already given, 0.2 you can write in both the equations. PB will come here, so 0.3 comes here. PA is going to come in the denominator in the second case, so 0.6 will come. So this is going to be 2 by 3 and this is going to be 1 by 3. So probability of A when B has happened is 2 by 3 and probability of B when A has happened is 1 by 3. So this is the reference for you. You can take a view out of it. A intersection B is given for two events 0.32, PB is given 0.5 and PA by B has to be found out. So A's probability when B event is known or it has already happened will be what? A and B intersection. It can be A intersection B, it can be B intersection A. Actually both are same and PB will come in the denominator. So the intersection is given 0.32, PB is already given 0.5. You can write it as 32 by 50 and the final will come as 0.64. Now if you are confused, whether my question answer is correct or not. So just remember that the probability will always lie between 0 and 1, 0 and 1 inclusive. 0.64 is between them. So just go ahead. It's correct. Now this is how we are going to do it. And you are quite aware of this formula now. So these are just starters. We have PA, PB, PB by A is given, PA by B and PA union B has to be found out. So what all is given has to be written first. This is very important so that you are aware that these all are given and this can be used for the computation of non-known activities or non-known values. So PB by A is PA intersection B and whichever is already happened, this A is going to come in the denominator. Now PA will come in the denominator. A intersection B, it is given or not? Oh, it's not given. So let's write PA intersection B like this. PA is given. Yes, of course, 0.4 is given. PB by A is given. Yes, it's 0.6. So write it here, 0.6. So PA intersection B, this equals 0.6 into 0.4, which is 0.24. 6 4s are 24. Now coming to PA by B, because A intersection B is known now. So this will be quite easy because we are aware of the formula. PA by B is going to be PA intersection B divided by what has already happened here, PB. So it will go in the denominator. 0.24 we have just computed. PB was already given 0.8. 8 3 is 24. 0.3 is going to be the result. Now PA union B, for that we have a separate result or formula. In previous exercises also we have talked about it. So PA union B is going to be equal to PA plus PB and then the intersection of A and B. That is, if you have two events A and B. Now why are you subtracting A intersection B? Because when you are unioning it, you are adding A and B. That is, in A the intersection part is there, in B also the intersection part is there. So you are adding intersection part twice. So you have to subtract it. So what is PA is 0.4. What is PB is 0.8 and PA intersection B, we have computed it 0.24 and this is going to be 0.96. PA union B is 0.96. Now this is how it's going to be done and all those things which are given has to be written like this and then we use the formula and this one we have introduced in this exercise for the first time. PA by B, PB by A, PA intersection B will be used and PA union B will be computed using again the PA intersection B. Now you have A and B two events, PA is given, PB is given, A union B is given which is 5 by 12, A by B and B by A has to be computed. So we have used a formula just now which is PA union B which is equal to PA. Whenever I'm calling PA, it's actually probability of A. PB is probability of B. So just understand that these are the way of saying the probability. So PA intersection B has to be subtracted. PA union B is given. So write it here 5 by 12. PA is 1 by 3 and PB is 1 by 4. PA intersection B can be computed here 1 by 3 plus 1 by 4 minus 5 by 12. And PA intersection B is going to be used in both of them. PA by B and PB by A. What is PA intersection B? 1 by 3 plus 1 by 4 minus 5 by 12. That means this is going to be 1 by 6. See, 4 plus 3 by 4 is 12. So it will be 7 by 12 like this. So 7 minus 2 by 12 will be 1 by 6. So PA by B and PB by A I'm writing side by side. Just to let you know that the P intersection B is going to come in the numerator of both the computations. And in the denominator PB will come on the left and on the right PA will come. P intersection B we have already computed just now. 1 by 6 can be placed in place of PA intersection B. PB is 1 by 4. PA is 1 by 3. So let's write 1 by 3 here. So this is 4 by 6 and this is 3 by 6. So 2 by 3 which is PA by B. When B has already happened or the probability of B is already known or the event has happened, the probability of A and vice versa in this case, which is going to be 1 by 2 because 3 by 6 is 1 by 2. Now how it is going to be done, which is in front of you. All the values have to be written first, use the formula and then the normal formula for PA by B, PB by A. All the mathematical symbols are there. When you ride a bike, you need to follow certain rules on the road. Otherwise, accident may happen. So these are the rules of the mathematics. All these things you have to use. A and B are two events such that PA is given, PB is given, PA union B is given, PA intersection B and PA by B, PB by A. Now we have just completed a question like this. So I would like you to refer to that question when the value has changed. Other things remains the same. And if you have any problem, just take this reference or let me know. We can do it again. A and B are two events such that PA is given, PB is given, PA intersection B is also given. Now we have to find out PA naught by B. Now PA naught means what is not probability of not A happening when B is already known. Okay, don't get confused. I'll just show you that these are just the way of asking questions. So probability of A naught by B is simply PA naught intersection B divided by PB. So this is the formula we are going to employ, and please keep an eye on this formula because I'm going to directly use it. So we need that this intersection A naught intersection B or A complement intersection B. Now A naught intersection B, you know the formula of this. What is that formula? In the theory of sets and via the Venn diagram, you understand that you subtract the PA intersection B from PB. That is, if I want to show you using the Venn diagram, this is your A and this is B, AB. Now you want the intersection of B along with what is not A. What is not A? Not A is of course B only. But you have to remove the intersection part, then only it will come, because there will be a part of A in A intersection B. So in all PB, if you just subtract the area of A and B intersection, because you want to remove all the parts of A that is lying in B as well. That is why PB minus PA intersection B is the formula which we are going to use in the upcoming questions also, so you need to understand it very well. PB is given 9 by 13, PA intersection B is 4 by 13. 9 minus 4 by 13 is 5 by 13. So PA complement you can write, PA naught you can write, intersection B is going to be 5 by 13. Now I have already used or intimated you the formula which I'm going to use just now. PA complement or PA naught divided by B, or sorry, it's by B, is 5 by 13 because PA naught intersection B is 5 by 13. PB is 9 by 13. This is going to be 5 by 9. So this is how it is going to be done. So I told you and I showed you how actually this is going to come through the diagram, but the formula or the way of doing the conditional probability remains the same. Next one is PA is given, B is given, PA intersection B is given. So A by B has to be computed, B by A is to be computed, PA naught by B is to be computed, and PA naught by B naught has to be computed. Now those which can be computed easily, let's start with that, because A intersection B is already given and PA by B and PB by A can be easily computed with this. First of all, PA naught by B, this is simply the both event has to be intersected. A naught intersection B and divided by what is already known, which is PB, goes into the denominator. How about PA naught by B naught? This is first you intersect these two, PA naught intersection B naught. This is the intersection, and in the division, PB naught is going to come. Now you see here, there are certain values which are not known to us. First is PB naught is not known, PA naught intersection B is not known, and PA naught intersection B naught is not known. All other things are actually given to us. So PA by B and PB by A, that I already told you that this can be computed easily. PA intersection B will come in the numerator of both of them. PB is going to come for the first case in the denominator. PA intersection B is again in the numerator, but the denominator will have the event which has already happened, which is PA. Now let's put the values. This is going to come easily. 1 by 4 is there. PB is also known, 1 by 3. Here on the right, it's PA intersection B, which is 1 by 4 again. And PA is also given 1 by 2. So this will come as 3 by 4. And this is going to come as 2 by 4, which is 1 by 2. Now, two probabilities the question is asking is already being computed. Now, coming down to this one. First thing, what is PB naught? PB naught is simply 1 minus PB. Anything which is the complement has the value which is subtracted from 1, which is the probability scenario. 1 minus PB is PB naught. So 1 minus 1 by 3 is 2 by 3. PB naught is computed now. Now what do we need for all the other two? We need PA naught intersection B. The numerator of PA naught divided by B needs it. That's why we are computing it. So PB, if you subtract PA intersection B, which I already told you in the previous question. So just subtract these two. PB we have computed, which is 2 by 3 just now. PB, no, it is given 1 by 3. PA intersection B has already been given in this question, which is 1 by 4. So 1 by 3 minus 1 by 4 is 4 minus 3 by 4, 3 is 12. It is going to be 1 by 12. So 1 by 12 has come. Now we are ready for PA naught divided by B computation. Okay, let's do it first. PA naught by B. The formula I am writing again, which is PA naught intersection B, A complement intersection B divided by PB. Now we have just computed PA naught intersection B, which is 1 by 12. PB is what? It is already given in the question, which is 1 by 3. So this will be 3 by 12, which comes out to be 1 by 4. Alright. Now coming to the last one. All others are computed. PA naught by B naught. So PA naught by B naught is simply PA naught intersection B naught divided by PB naught. Now PB naught we computed 1 minus PB we have already done, and that was 2 by 3. 1 minus 1 by 3 was 2 by 3. You already know that. We have just done it. Now coming to PA naught intersection B naught. See, I am writing the complement also and the bar also above the letter. That is, both the things are not or complement. So PA naught intersection B naught is PA union B whole naught. That is whole bar. This is, we are using the De Morgan's law, which we have learned in earlier grades in this set. So 1 minus PA union B, anything complement can be computed by subtracting it by 1. That's what we have done with PB. PB naught was 1 minus PB. And PB is equal to 1 minus PB naught. That is how it goes. So PA union B is what? PA plus PB minus PA intersection B. And these all are given actually. So 1 by 2 is PA, 1 by 3 is PB, and PA intersection B is 1 by 4. So PA union B is, by all values which are given, it will be 7 by 12, because on the left, if you see, we need PA union B. That's why we computed PA union B. So 1 minus PA union B, which we have just computed as 7 by 12. So this is 5 by 12. Now using all these which we have computed in the equation, 5 by 12. 2 by 3 was already written by me, if you remember. So this comes out to be 5 by 12 into 3 by 2. 3 4 is 12. 5 by 8 is going to come for PA naught divided or by B naught. So I have explained you all these separately, and let me also show you the formal way of doing it. So this is how you're going to go about. It was a good question. It may come in 4 to 5 marks. This question we'll discuss in the later part. Thank you so much. Have a good one.